Okay, good afternoon, everyone. Let's continue on with reading our book. Um, so let's get right on to it. Oh, wow. How about two of them? Oh, so that's where it went. Okay, let's see. What do I do here? Let's put this here, and then let's close this, and then let's put this here on its own. I really need to get some tiling going on, but okay, okay. Let's begin our reading. So, array variables are like pointers. When you create an array, the array variable can be used as a pointer to the start of the array in memory. So again, remember, just like the picture, right? If we looked at the array here, right, with a lot of things, that zeroth index here is actually the starting point of the array, right? So in this case, this is quote, right? So the variable quote actually points to zeroth, uh, I guess, index, which is basically zero offset from this block of memory allocated, right, for the string. So it'd be COOKIES, right? So when C sees a line of code in a function like this, so character, right, char quote array equals cookies make you fat, the quote variable will represent the address of the first character in the string. So this is the quote variable, right? So this quote here points to the first address where it actually contains capital C. The computer will set aside space on the stack for each of the characters in the string. So just a reminder, we imagine memory, right, as infinitely growing to a certain point. Infinitely growing. If we imagine a lot of memory, okay, all this could actually represent our program, but only this part is like the stack of our program, which is going to be like main, for instance, right? It could extend beyond this variable. So every time the quote variable is used in the code, the computer will substitute it with the address of the first character in a string. In fact, an array variable is just like a pointer. Okay, so notice how we when you do printf here with the %p, this is, even though this is an array, you'll still print out the pointer, which is going to be the first address. Like we did do this example, right? So our function was passed a pointer. Okay, so here, this was their trying to solve this problem here, where if you do size of whatever has been passed, okay, to the function, which is an array, you would have expected the size of to count the characters in the array, but it didn't. It actually gave you back 8 bytes, which is actually the size of the memory address, right? So what they're trying to say here is that when you call fortune cookie with your array as an argument, that array is actually just the first address, the first character, right? So the address of the first character, an address in this case is a pointer, right? And every address in your computer is 64 bits. So that is why size of message here is 8 bytes. Okay, so that's why that weird thing happened in the fortune cookie code. Even though it looked like you were passing a string to the fortune cookie function, you were actually just passing a pointer to it. Okay? I encourage everyone to try this out. And that's why the size of operator returned a weird result. It was just returning the size of a pointer to a string. On 32-bit operating systems, a pointer takes 4 bytes of memory. On 64-bit operating systems, a pointer takes 8 bytes, right? So our computer is a 64-bit computer, so we have every address is 8 bytes. So here's how the computer thinks when it runs our code. So the computer sees a function, okay, void fortune cookie, right, with this message as a parameter. The computer goes, looks like they intend to pass an array to this function. That means the function will receive the value of the array variable, which will be an address. So message will be a pointer to a character. So in this case, they're saying something like, it's actually this is basically the same thing as oops. Ugh. Yeah. I can't even draw an ampersand to it at that angle. But that pointer will point to the address of the first element, right? This is not equal. I'm just saying that it's like equivalent to like how you should think about it. Then it sees the function contents, right? So this is the contents of what's inside here. I can print the message, right? So the message here, it starts from the first, right? First element of that memory block, right? All the way up until it sees a null character. So it starts from, I don't know, cookies, right? C, and it reads all the way until it reads the null character. So that is the string here. And when we call size of message, actually we're not calling the size of for this entire block of memory. We're just calling the size of the address pointed to the first character. So I can print the message because I know it starts at location message. Size of message, that's a pointer variable. So the answer is 8 bytes because that's how much memory it takes for me to store a pointer. So then the computer calls the function right here. So we declare an array, right? An array of characters. Cookies make you fat. Then we pass this into this function, which is actually going to be literally just the base address, like the address of the first character. And from there, we kind of just move consecutively, right? So quote's an array, and I've got to pass the quote variable to fortune cookie. I'll set the message argument to the address where the quote array starts in memory. So again, if this is the quote array, we start here, right? And so we're passing that address, this one right here. All right, sorry for the mess. So, important things to note. An array variable can be used as a pointer, okay? Basically, if you had something like this, right? You can always reference it just like this, and that will be treated as a pointer type, okay? The array variable points to the first element in the array. If you declare an array argument to a function, just like up here, right? If you declare an array argument to a function, it will be treated as a pointer. So that's when you use the function and you pass the array in, it's going to act as if it was a pointer, okay? The size of operator returns the space taken by a piece of data. And you can call size of for a data type, just like size of int. Size of a pointer returns 4 bytes, right, on 32-bit operating systems and 8 bytes on 64-bit operating systems. Cool. There are no dumb questions. The size of a function, no, it's an operator. So what's the difference? An operator is compiled to a sequence of instructions by the compiler. But if the code calls a function, it has to jump to a separate piece of code. So is size of calculated when the program is compiled? Size of calculated, yeah. The compiler can determine the size of the storage at compile time, okay? So every time you do size of, it's actually an operator you can use and expect it to be kind of solved, like evaluated, calculated, computed, whatever, when your code compiles at that point. Depends on, like, if it's like size of int, that's fine. Size of, I guess, an array, right? That an array of characters is fine. But I think when we start to dynamically allocate memory, maybe it might not be. So, and we'll talk about that soon. And you can, right? Like you can actually, in C, just for a sneak peek, you don't always have to allocate some fixed block of memory, right? You can actually, for example, like get some input from a user and actually allocate maybe just a teeny tiny bit of memory or a large piece of memory. So why are pointers different sizes on different machines? On 32-bit operating systems, a memory address is stored as a 32-bit number. Okay, that's why it's called a 32-bit system. 32 bits is 4 bytes, and that's why a 64-bit system uses 8 bytes to store an address. So if I create a pointer variable, does the pointer variable live in memory? Yes, a pointer variable is just a variable storing a number, right? So this goes back to what I was saying. Like, it's hard to tell whether or not this is going to be an integer or like a long integer or a pointer, and that's the reason why we have that specific notation to help us know that this number is actually a memory address, or in other words, this variable is a pointer. So can I find the address of a pointer variable? Yes, you can find the address of a pointer variable using the ampersand operator. Can I convert a pointer to an ordinary number? On most systems, yes. C compilers typically make the long data type the same size as a memory address. So long int, right? So if P is a pointer and you want to store it in a long variable, by the way, long is short for long int. So this this here long, right, is the same as long int. Okay. You can type. Okay, so we can actually convert a pointer variable, which is an address, to a long int. Okay. On most systems, or is it not guaranteed? It's not guaranteed. Okay, sure. And this is what? This is a mating game? That's kind of weird. Um, we have a classic of we have a classic trio of bachelors ready to play the mating game today. Tonight's lucky lady is going to pick one of these fine contestants. Who will she choose? Contestant 1, 2, or 3? I'm going to pick contestant number, let's see. So you'll initialize an array of contestants 1, 2, 3, and then the choice here is going to be the first. It looks like the address to the first contestant, right? Because if we look at this memory variable here, we have, in this case, contestant 1, contestant 2, contestant 3, and this is the contestants variable. Right? And it points to the first entry. So that makes sense. Choice will be here. So far, so good for me. Contestant 0 will be 2. Okay, contestants at 0 is going to be assigned to 2. Okay, and then contestants 1, which is here, is going to be it's going to be the dereference of choice. So take the memory address at choice and then get the value in there because of the asterisk, and that is 2. So we assign that to 2 at index 1. So I should probably write the index here. So 2 becomes 2. And now at contestants index 2 right here, we dig into the value of choice again, and that's 2. And then so we change that to 2. So she's just going to pick contestant number 2. Let's see. Yeah, we did it. right? We did it. I suggest you do this exercise. This is fun. This is tricky actually because it wants to see if we know whether or not the first like the array variable is actually pointing to the first memory address, right? So this is good. It turns out to be 2. Okay. So yeah, choice is now the address of the contestants array. See, and that's just basically pointing to the first element. Okay. Ooh, but they're gotchas, it looks like. Okay, but array variables aren't quite pointers. Even though you can use an array variable as a pointer, there are still a few differences. To see the differences, think about this piece of code. Okay, so we have an array of strings or of characters, HOW space BIG space IS space IT question mark and then a null terminating character at the end, right? So then we declare a pointer variable t to point to s, which is going to be the first letter of that array. So let's just kind of again draw it. Okay, so we'll have H O W space, then we'll have B I G space I S space I T, then we'll have question mark. Then I guess we can just kind of put the null terminating character right here. Whatever. So then we'll have S point to here, right? Because that's the array. Let me answer my phone. Okay. And then we declare a pointer variable t that points to s, where s is. So t is actually now pointing to the same place. T is pointing to the same place as s. Okay. Now, size of an array is the size of the array, right? So we did size of s, that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, something like this. Okay. Oh yeah, this returns 15. Okay, so we've seen that size of a pointer returns the value for 8. That's the number of bytes. Because that's the size of pointers on 32 and 64-bit systems. But if you call size of on an array variable, okay, calling it size of here, okay, not when we pass it to a function where it becomes a pointer, but just like straight up, right? C is smart enough to understand that what you want to know is how big the array is in memory. Okay, so it's 15 bytes. But the address of an array is the address. The address of the array is the address of the array. A pointer variable is just a variable that stores a memory address. Okay, sure. So T is storing a memory address, right? T is going to be technically like something like this. The address of the first element of the array S. Something like this. Okay? So what about an array variable? If you use the ampersand operator on an array variable, the result equals to the array variable itself. That is true. If a coder writes ampersand S, that means what is the address of the S array? The address of the S array is just S. So it's also saying that, well, okay, well, since S is pointing the first element right here, so it's technically just this, right? Or kind of, actually, yeah, just, it's not, it's technically just this, right? So, because an array is treated as, an array is actually just treated as a pointer variable to the first element. Okay, the compiler, so the computer will allocate space to store the variable, but it won't allocate any memory to store the array variable. The compiler simply plugs in the address of the start of the array. Okay. Oh, oops, I read this was a the address of the S array is just S, but if someone writes ampersand T, that means what is the address of the T variable? Okay. An array variable can't point anywhere else. When you create a pointer variable, the machine will allocate 4 or 8 bytes of space to store it. When you create a pointer variable, the machine will only allocate 4 or 8 bytes to store it. That's true. Remember we did this null thing where we didn't allocate any bytes to store the address, but actually when we then initialized it to something else, we were able to store something. Yeah, that was the one example that I struggled with a couple of days ago. But what if you create an array? The computer will allocate space to store the array, but it won't allocate any memory to store the array variable. The compiler simply plugs in the address of the start of the array. But because array variables don't have allocated storage, it means you cannot point them to anything else. So we can't repoint things. That's cool. So we can't just take this array variable here and then just do this. Oh, okay, let's point to the same place. Because if we actually change t to, let's say, point here, doing this will not work. We cannot repoint s to that place where t is. Okay? Because pointer variables are, or because array variables are slightly different from pointer variables, you need to be careful when you assign arrays to pointers. If you assign an array to a pointer variable, then the pointer variable will only contain the address of the array. The pointer doesn't know anything about the size of the array. So yeah, so when we have the array here, especially a character array, we kind of infer the size of the array by going all the way up to this, right? The null terminating character. Okay? But if we kind of mess around with I guess the pointer, we kind of lose track of how big something should be. So that's why we have to be explicit on the size. So every time you pass or address the array, the pointer doesn't know anything about the size of the array, so a little information has been lost. That loss of information is called decay. Every time you pass an array to a function, you'll decay to a pointer, so it's unavoidable. But you need to keep track where arrays decay in your code, because it can cause very subtle bugs. Okay. Let's skip that. Let's skip this, I guess. Actually, no, let's do it. So the case of the lethal list. Oh, it's one of these stories where the gold digger or something. The mansion had all the things he dreamed of: landscaped grounds, chandeliers, its own bathroom. The 94-year-old Amory Mumford III had been found dead in the garden, apparently of a heart attack. Natural causes? The doc thought it was an overdose of heart medication. Something stank here, and it wasn't just the dead guy in the gazebo. Walking past the cops in the hall, he approached Mumford's newly widowed 27-year-old wife, Bubbles. I don't understand. He was always so careful with his medication. Here's the list of doses. She showed him the code from the drug dispenser. Int doses 1, 3, 2, 1000. So the first dose at index 0 is 1, second is 3, third is 2, and then the fourth dose is 1000, whatever, maybe like 1000 milligrams or something. The police say I reprogrammed the dispenser, but I'm no good with technology. They say I wrote this code, but I don't even think it'll compile. Will it? She slipped her manicured fingers into her purse and handed him a copy of the program the police had found lying by the millionaire's bed. It certainly didn't look like it would compile. Print, issue dose number. 3 doses, like this. Doses, okay? Interesting. What did the expression 3 square bracket doses square bracket mean? 3 wasn't an array. Bubbles blew her nose. I could never write that. And anyway, a dose of 3 is not so bad, is it? A dose of size 3 wouldn't have killed the old guy, but maybe there was more to his code than met the eye. Yeah, let's find out what this is, because I don't know what this is, actually. Okay, why arrays really start at 0. This is going to be interesting. An array variable can be used as a pointer to the first element in an array. That means you can read the first element of an array either by using the brackets notation or using the star operator like this. Okay, so these two are the same, which is, I think, what I've been trying to do this whole time, right? Like, yeah, like something like this. Oops. Yeah, I've been trying to do something similar like this the whole time. Okay, so yeah, because an address is just a number, that means you can do pointer arithmetic and actually add values to a pointer value and find the next address. So you can either use brackets to read the element with index 2, or you can just add 2 to the address of the first element, right? So if we did something like this here with doses, it was like 1, what was it? 3, 2, and 1,000, right? Doses points to here. This is 0, 1, 2, 3. Okay. Okay. So means okay. So where did we go? Okay, okay. So what we're saying here is that doses start at 0. So if I did maybe doses plus 1, that is actually going to be here. And if we dereference that, we get this value here. That's how we access that. Okay, yeah, see, third order drinks plus 2. So let's just say doses plus 2, right? So we're going to end up here. And if we want to dereference that and print that out, that would be the number 2. So then we said doses plus 3. So doses plus 3. We end up at this memory address, but then we want to dereference that. Okay, when we dereference the base of dose plus 3, so 1, 2, 3, dereference, dig into that memory address, we get 1,000. Okay, so in general, the two expressions drinks I and drinks plus I dereference are equivalent. That's why arrays would begin with index 0. The index is just a number that's added to the pointer to find the location of the element. Use the power of pointer arithmetic to mend a broken heart. This function will skip the first 6 characters of the text message. Okay, so skip, so put S, what? Put S, something like percent %S, MSG plus 6, and then dereference it, so something like this. And I think it's just this, right? We don't need a dereference, do we? Dereferencing would just get the character at that place, but then we're technically printing the string, so we just need to pass in the memory address. So we could say something like this: skipped string. Oops. Let's just do this. Skip string is just message plus 6, right? I think that's it. But then they're probably gonna put this right away into like a percent %S thing. They'll probably do something like this. Oops. Yeah, something like this, and then this down here. Yeah, see, let's just do that because then it'll start at the sixth offset, and it'll just keep printing until it hits a null terminating character. It's just like skipping. So that's why you can actually start at any place in the string. Okay, so what they're saying is that this is the same thing. You just kind of print that out, and then you print this out, and so on. Okay, so why pointers have types? If pointers are just addresses, then why do pointer variables have types? Why can't you just store all pointers in some sort of general pointer variable? Yeah, like why do we have int star? Why do we have character star? Why do we have long star? Why do we have short star? The reason is that pointer arithmetic is sneaky. If you add 1 to a character pointer, the pointer will point to the very next memory address because a character is just 1 byte of memory. Okay? But what if you had an int pointer? Ints usually take 4 bytes of space. So if you add 1 to an int pointer, it is actually adding 4 to the memory address. Just keep that in mind. So going back to here, the memory address, these are actually 4 away from each other. 4 bytes away from each other. Because an integer takes up 4 bytes of space, right? So when you do, let's say my int, right, plus, or my int array plus 1, you're actually saying, okay, I want to go to the next integer over. If this is actually an int star, I want to go to the next integer over by 1. That's actually doing 4 addresses because I think 1 byte is 1 address, right? So now, if we want to go to the next character or next integer in the array, it'll be 4 memory addresses over. So if this is actually a long star, plus 1 actually means to jump 8 bytes over. So this is what we call pointer arithmetic. So when you're doing plus 1, plus 2, plus 3, whatever, it's not really just pointing to the next memory address, but rather pointing to the next memory address of the valid element. So something like int star pointers will jump 4 addresses. Longs, pointer to longs will jump 8 because it's 64-bit. Pointer to shorts will jump 2, and characters will jump 1. And that's the reason why characters are so convenient in C, at least the way it is right now. By incrementing a character pointer by 1, you're just jumping 1 memory address. But you have to keep that in mind, right? If you have an array of integers and you're incrementing the pointer by 1, 2, 3, or 4, let's say you increment by 3, right? So 3 is not really 3 memory addresses. It's actually 3 spots, right? So 3, where you have 3 offset, but then each integer is 4 bytes, so it's 3 times 4. You're actually hopping 12 memory addresses. So the compiler is kind of smart to do this, so as long as you're strict with this type definition. Okay, let's finally answer this story. So the case of the lethal list. So last time we left our hero interviewing Bubbles Mumford, whose husband had been given an overdose as a result of suspicious code. Was Bubbles the coding culprit or just a patsy? I don't know what that is. What's a patsy? To find out, read on. He put the code into his pocket. It's been a pleasure, Mrs. Mumford. I don't think I need to bother you anymore. He shook her by the hand. Thank you, she said, wiping the tears from her baby blue eyes. You've been so kind. Not so fast, sister. Bubbles barely had time to gasp before he'd slapped the bracelets on her. I can tell from your hacker manicure that you know more than you say about this crime. No one gets fingertip calluses like hers without logging plenty of time on the keyboard. Bubbles, you know a lot more about C than you let on. take a look at this code again. Okay, so we have this. I knew something was wrong when I saw the expression 3 doses. You knew you could use an array variable like doses as a pointer. The fatal 1000 doses could be written down like this. He scribbled down a few coding options on his second best Kleenex. Doses 3 is actually this, right? But then that is the same thing as this, right? Commutative property, which then translates to this. So you can actually do this in C. That's pretty crazy. Because you're just... So this here is equivalent to this, right? And if we read that, it's just flipped. Take this memory address as 0, for instance. Now, we are at 1, 2, 3. So we're actually starting at memory address 3, and we want to offset all the way down to doses, or something like this, right? 3, and then, yeah, offset to doses. I think we'll land at 1000 in one part of the memory. That's pretty crazy. Wow, I never knew you could do that. But I guess it makes sense. So memory address at 3 plus the address of doses. Yeah, you'll end up three away. Huh. So this here, actually, if doses starts out at, like, let's say 1300, and then so that is like, what was it, 1, and then 1301 is 2, 1302 is 3, 1303 is the 1000 dosed, right? If we start at 3 and then we plus doses, which is going to be the base address here, 1300, we'll get 1303, and that actually points to this value here. That is so cool. Wow. Wow. Your code was a dead giveaway, sister. It issued a dose of 1000 to the old guy. So it's just commutative property. And now you're going where you can never corruptly use C syntax again. So yeah, so just keep in mind, like, I think the way they did it was actually this was starting at 3. Normally we think of it like this, where it's like, 1 to 3 to 1000, right? Normally we start here. We think about doses here, and then we plus 3 to get down to here. So we do it the opposite. We start at doses and then we add 3, but this one's actually starting at 3 and then add doses. Cool. All right, let's finish this up, and then I think that's good for today. Some bullet points. Array variables can be used as pointers, but array variables are not quite the same. Size of is different for array and pointer variables. Array variables can't point to anything else. Passing an array variable to a pointer decays it. Arrays start at 0 because of pointer arithmetic, and pointer variables have types so they can adjust their pointer arithmetic. Okay? Do I really need to understand pointer arithmetic? Some coders avoid using pointer arithmetic because it's easy to get wrong, but it can be used to process arrays of data efficiently. Can I subtract numbers from pointers? Yes, but be careful that you don't go back before the start of the allocated space in an array. So that means you can't go past the first, like, base address, right? When does C adjust the pointer arithmetic calculations? It happens when the compiler is generating the executable. So when it's turning that code into something that can be run, binary. It looks at the type of the variable and multiplies the plus and minuses by the size of the underlying variable. Go on. If the compiler sees that you are working with an int array and you're adding 2, the compiler will multiply that by 4, which is 32 bits, the length of an int, and then add 8. So 8 spots down. Does C use the size of operator when it's adjusting pointer arithmetic? Effectively. The size of operator is also resolved at compile time, and both size of and the pointer arithmetic operations will use the same sizes for different data types. Can I multiply pointers? Flat out, no. All right, I think we're making good progress. Let's stop for today. Bye bye.